Hello, my name is Randy Stout. I'm an associate professor in the Department of Biomedical Sciences at the College of Osteopathic Medicine here at NYIT, and I'm the scientific director of the BRIC. And I'm here with three students who have been helping me out and using some exciting new technology. We have first-year medical student Kristen Ferrara, Simon Sambowski, and Ariel Rep are joining us today. And we're here today to talk about virtual reality and other emerging technologies and how these are contributing to medical education. And so just to get us started out, I'll actually turn it over to Simon. I know you've been here for helping me out over the course of this, and so I'll turn it over to you, and then you can ask me a few questions, and then we can talk more about the program that we ran over the last month or so, and then
Yeah. So I guess a great first question would be, what encouraged you or inspired you to bring this virtual reality program to NYIT Com?
Yeah, so I've always been interested in things like sculpting, and my background in research, and really my primary focus for the last 7 years of being here, it's actually getting towards to 9 years. The time flies when you're having fun. But for the past over 8 years that I've been here, my primary focus has been research. And so when I do cell biology using microscopy, and one of my goals was to build a virtual model of a cell. And so when I came here, I met another faculty member who had been using virtual reality to do sculpting and build new digital objects. And so I tested it out for that purpose, and just started to see the expanded opportunities for using virtual reality and things like spatial computing and the beginnings of artificial intelligence, even back then, using deep learning and stuff like that. So I saw the opportunities that the new technology presented, and that allowed me to, think about ways that I could help enhance the medical education and prepare students for the future. So I started using sculpting programs in virtual reality and building things. Yeah. So that's why I brought it in here, using it both for research and for teaching over the last 9 years or so, almost 9 years now. So, yeah.
And it's been a pretty cool process throughout, like watching you and working together and collaborating on this. I feel like it has made a big difference, and Kristen will talk about it in a second about her experiences with as a participant in this. But I've known you tried to do this virtual reality thing in the past. How did you feel like this year's attempt at it went?
Yeah, so this year was the best yet, I can definitely say, and I think we learn something every time we do stuff like this. So we really started out with the biggest project in 2018. We had over 300 students use a kidney nephrology training program for the second-year medical students. That went great. There's a lot of logistical issues that come behind integrating and deploying with the correct learning material to a virtual reality experience for education. The technology has changed and grown since then. Newer headsets. Back then we were using, each person had to have their own laptop, and they had older headsets with lower resolution. Everything was a little bit harder, basically. And then we've been just developing year after year and trying to make it better with regard to the ability to deploy this and the ability to provide better and better learning material. So one of the reasons why neuroanatomy is so important for this is because, and I'll let you guys kind of talk about it, maybe Ariel can jump in, but the structures that you're seeing and you're trying to learn, they're very hard to see. They're inside an opaque central nervous system, like the brainstem, for example. And you can often not see that in real life, even though we have the great cadaver lab with the people that donate their bodies. but some of these structures you just can't see in real life. And so you can look at a virtual model on the screen, but it's not the same as being able to be right there with it and being able to manipulate and move things around. So yeah, you were here for a lot of the different structures, and you also had neuroanatomy. So what do you think about that?
I think it takes something that you sort of get one chance when you're working with those cadavers in the neuroanatomy lab, which is great to see it, in the lab. But what we do through virtual reality is we suddenly have this, it's almost like a Lego set that we can break apart and put back together and color coordinate and, pull certain pieces out and put them back in. So it just, and then walk around it too. And so it gave us a lot of flexibility in structures that I think are otherwise very vague when you see them on a fixed cadaver brain. It's the flexibility, it's that people can see it in a way that they won't see it in the labs. And I think everyone learns a little bit differently. And so getting to play with it in their own way versus the brains that we have to be very gentle with. I know we're working, you mentioned the newer VR headsets, and that they're continually improving.
Yeah, Ariel, with regard to like being able to walk around and move things around and do that with other people, that's what we're doing in the lab, but we also have the expanded capabilities of a computer system where you can redo, undo, all of that type of stuff. It's all digital. And those are just new ways of interacting with the learning material that aren't possible in the cadaver lab. It has benefits. There's other things, complementary benefits here. And if you remember, I probably said it to you during your first year in neuroanatomy when we were up in the lab, you have to start to build a mental map or a mental simulation in your own mind of where these structures are and where they are in relation to each other. That's the challenge. And to build that kind of map of the brain structures that you can just picture in your own mind, that's what we're doing with virtual reality. And then you're able to see a map that's already been generated. You're able to interact with it, modify it. And that loop of doing and seeing and visualizing, and in this case, 3 dimensions, we're hoping that really helps and improve the outcomes with regard to the time spent learning. Yeah. We have, and it's complemented by the new technology. So every year we've had the great opportunity of being supported in being able to add to the equipment that we have available, the higher resolution headsets. Now these headsets have, and we used this to great effect actually this year, these headsets have these outward facing cameras which actually can beam the images into the headset. And you can see why that would be helpful when you're interacting with people in the same space. But another big benefit of it was our ability to have you as our facilitators and helping me. A lot of students never have been in virtual reality before. I don't know, Kristen, have you used virtual reality?
I never did. Yeah,
oh, really? Oh, okay.
I've never put on a headset. This was my first time, so it was an incredible experience because I really got a very good exposure very quickly on how to work everything. Yeah. And the ease of, sometimes you look at equipment, you get intimidated, and you're like, how am I going to? It was, basically like riding a bike after like the second or third session. So like building on like even exposing this to students who have never used a headset like myself, it's very accessible. Anyone can do it. So that's what makes it, what I really liked about it was like the ease and like how comfortable I felt. And, you were great at explaining just the controller, how to, build. And it was just a really good, like seamless transition, like week to week, which is what I really liked. I really loved also, I'm pivoting a little, but from what you said, just about the flexibility of everything, it was also, I completely agree. And also I just felt like VR takes like the fear out of like exploring. So when you're in the anatomy lab, it's incredible. And you have this like, all these emotions are going through you because you're looking at these cadavers, these people who donated their bodies and like people who've never seen a body before. You go in and you're like, how do I even navigate this? and you have kind of like a fear sometimes of, you know, maybe touching or looking at something, especially something as delicate as the brain, where, you know, it's a lot, everything is really small. So you sometimes feel a little nervous to touch that or do that. But with VR, like, you have this, like, your inhibitions, you can do basically whatever, and you have the freedom and like the comfort of like moving forward and like grabbing a medulla with your hand, or like looking at the amygdala, or like doing things with vessels, and being able to have that like freedom to do it without the fear of, like, you know, you're, you know, touching a physical body. So.
You encouraged people to mess up.
Yeah. And it's that action directly affecting something through your own actions, and then seeing how the system where you're learning changes in response. That's a powerful way to aid in learning, because it's actually you doing it, and then you're seeing the expected results, and then determining, you know, was that thing really behind there? Was that loop the way I expect it to be based upon my initial viewing and stuff like that? We also the pass-through, for example, allows us to project the virtual learning material. So in this case, like the cranial nerve nuclei in the brainstem, we can make them bigger and smaller, but we're projecting it into virtual space, but we're able to see the world around us. So that allows me to then turn to somebody in the room and say, okay, well, if you grab it with your right hand and move it out, and then everybody that's interacting, we're all interacting in the same virtual space and seeing the same thing. It's both a social and an interactive learning experience. And every new iteration of the technology allows that to be better. And it is getting better. And so Simon, you and Ariel were really volunteering to come in here. And so what was your experience in having gone through the neuroanatomy itself, and then now helping me with this process? And it was really critical, the help that you provided. Over 12 sessions, you came in here after late at night, and I really appreciated that. Do you, what are your thoughts on, you know, what was different than you expected, or, you know, what you think could have been done differently that might have helped the students improve, or may allow us to expand this in some way?
Yeah. Well, I personally thought it was really, really helpful, and just seeing it as a second year, especially interacting with you, and like seeing you interact with the first year students. Like, you are a very like passionate educator, and you're very knowledgeable. So it's nice to see you like interact with the first year students and teaching them about neuroanatomy. And the neuroanatomy department does try their best to try to teach us these 3D relationships and stuff using 2D models. But it is very difficult at the end of the day just to get that point across using a 2D model. One specific example would be the spinal tracts. It's just very hard to see it with 2D paper and stuff like that. So seeing it in a 3D model, especially right after the first year students would have their regularly scheduled neuroanatomy lab time, I think was a great enforcer, especially with practice questions. Me and the other second year facilitators added practice questions to the virtual reality sessions to kind of reinforce ideas that they just learned, and to also show them in ways that these topics could be applied clinically. I actually want to ask you, Kristen, like how you thought about that system of having the virtual reality review right after having your regularly scheduled neuroanatomy lab.
It was great, and the reason why I loved it so much and why I was so active in coming is because the anatomy lab was a lot shorter than the other anatomy in the previous semester, which was a little longer because we were doing many different body systems at the same time. So when we were the lab was shorter, so in that time frame it was nice because I in my brain associated this as my lab. Like, I was like, okay, the first half of anatomy lab is going to be in the physical lab, and the other half is going to be VR. So we can just keep expanding and it's also fresh in your head too, right from lab. So doing it right after was really helpful, and just kind of like hitting home like all of the structures that we just saw, and then doing it in a different way. So, I mean, and it's also how I learn, and what I've learned has given me some success in med school, is just, since I'm a very kinetic learner, like being able to see everything and do everything like in VR right after a traditional lab course really just helped like solidify all the information.
Yeah.
So,
I mean, you, I think, use the term a mental map. And I personally, just like Simon said, they do an excellent job of teaching us in neuroanatomy, but I wouldn't say I had that mental map until I got into the VR headsets. It really upped the ante on my understanding of the human brain. And I think that, you know, it is a wow factor at first. I think the first couple of sessions, every time we had a new student, they'd sit down and the first 10 minutes was sort of corralling everyone because they were so blown away. It was so, you had this giant brain sitting in front of you. But once you progress, it really is, you start to walk around the brain and through it and cut it up and then put it back together.
Quiz each other and talk to, and go through the problem
fun.
areas, you know, the
Made it
things that we
fun.
you didn't get enough time on in the regular lab and stuff like that. We did 12 total sessions this year, which is an expansion from previous attempts at using and bringing virtual reality to neuroanatomy. And we did, for each lab, a new experience, and it was paired with the material that they learned in the lab. This was all voluntary. It was through a sign-up process. The students, and it was designed as a supplement. So there's other ways we can access this information, this learning material. This was a way that those students who felt like they would benefit from it could sign up and use it here. And we had some repeat customers. I think you came to all of the sessions?
I came to all of them,
Yeah.
yes. So I did really like it.
Yeah. Some people came once
Yeah.
and didn't come back.
Yeah, no,
and
I
it
was
depends.
just going to keep, I kept coming.
Yeah, and so some of the sessions, we used different technologies. We used one called Victory XR. We used the program Gravity Sketch as our kind of main teaching tool here. And these are programs that run in here, and everybody can access. Gravity Sketch is free, and it's a way that you can learn on these things. We also used scanning technology to bring in the same specimens, in some cases, into the actual lab itself. We had supported through, this was 2019, with now alumni, built most of the learning material that you were using in this year were built in 2019 by a group of 4 medical students who are now doing their residencies. So I know you felt like it was valuable. What were some of the, benefits that you saw with regard to where this technology might go and how this is not just specifically for neuroanatomy, and I invite Simon and Ariel to kind of talk about it too, but like when you're out and you're practicing, we don't know what the technology is going to be like. We know that there's robotic remote surgery.
I was just thinking that in my head.
Looking at three-dimensional things and trying to understand how images might be handled by AI, for example, all of this kind of emerging technology. What do you think about how that interacts with what the three of you did in the virtual reality program we ran today?
Yeah, what I think I really just love about medicine in general is that it's always changing. So when we graduate, I'm a first year and you guys are second years, like by the time we're in the field and we're out there, I feel like the world is going to be different. And especially with AI and, different advancements, everything is going to look different. And I feel like utilizing VR and being able to, even just learn how to use the headset or learn how to be kind of that tech savvy or like understand what we're doing, I feel like eventually in the future it will help us in the long run, because I feel like this is going to be incorporated more and more into medicine because it's going to keep on evolving.
This is not going to be the last time that we're, as medical students, using VR to be trained on something. I see it as the future for training, surgery. Yeah, practicing in VR on a cadaver before you practice on your patient, or taking the MRI or CT scan you have of your patient and uploading it, like you said you did with some of our cadaver images. And again, running through the procedure you plan on doing. That's the small scope. I feel like beyond that, it's also personally very fun. It's, it's going to help in your professional careers as far as meeting people maybe who you wouldn't have been able to meet at conferences or other practices. So I just think it has so many uses. So becoming more comfortable with it is very important.
Yeah, so you and Simon and Kat and Darina, the students who were helping with, they got a refresher and a new view onto some of this material, but you also experienced what it was like to organize and create a learning environment, create questions that fit with the rest of it. And hopefully we'll have first-year students who then take over your role in future iterations of this, and we're always looking to expand and improve. And I think it was highly successful, and I'm really glad that some people, I feel like, got a lot of
Yeah,
benefit.
I'm hooked, so I'll be back.
Yeah,
Yeah,
so
I'll
this
definitely be
is,
back,
and
so.
I have to thank Simon, Kat, and Ariel again. It's been a great experience, and every year we improve, and it's been a great year. And so, yeah, we're looking forward to the future and seeing what comes next in this type of technology.